The MCP protocol is relatively complex. For the easy part, the server can expose tools, prompts, and resources to the client. But it also supports notification initiated by the server to the client and a feature that looks weird at first called sampling. When you use MCP, the intelligence lives on the client. It's the client running the LLM that decides whether to use the tools, resources, and prompts exposed by the server. But what if the server needs an AI too? You could run an LLM on the server, but then the infrastructure and token costs are on the backend. MCP introduced sampling, which works the other way around. The server can ask the client to generate something with the AI and use the output to complete the tool call. Today, I will show you how it works with a simple example. Let's go. So briefly, here is a schema of how MCP works when you add sampling. So here we have a client on the left and a server on the right that expose a web tool that you can use to browse the web and get web page outputs. On the left, the client is asking to fetch the latest news about AI agents. So the first step here is the AI makes, let's say, a Google query input and sends it to the client that will make a call to the server to invoke the web tool with the search input. The web tool will use the browser to make the requests, and then at this moment it realized that it needs the AI to clean up the result before doing a few extra steps. So at this moment, using here the green color, we show the sampling. So the web tool makes a call back to the client, asking the model to generate something. So here maybe cleaning the web outputs. The client goes back to the AI, here Anthropic, for instance, that generates the output, send it back to the client that will send the generation to the server. Then the server can perform some extra steps to prepare the output, and it makes the final call to the MCP client to give back the final answer of the web tool. At this moment, the MCP client sends back the result to the AI on the client, and it generates the final response that will be showed in the chat application. Okay, so now we understand how sampling works. Let's dive into the code and build a server that uses sampling. So the first step here is we create an MCP server. We use the SSE protocol, so I attach it to a FastAPI application, but it works also with the local setup. So here I created the MCP application first. I create a tool called generate poem, but this tool needs to invoke an AI to generate the poem. So at this point here, we use the context from the MCP server to make a sample call. It will call the client to ask for a generation, and then we print the response here and return the text. So here it's really simple. We just use the local LLM from the client to generate the output, and we just send it back. So it's just a simple example. Then I create the FastAPI application. Here I have a sample route, but it's not important, just to show that the two can live together. So you have your MCP and your FastAPI. And then I mount the SSE application from MCP to the / route in the FastAPI server. Now we can take a look at the client. So the client, it's relatively simple. We load the environment to load the API keys, and then we create an Anthropic client. So now we need to create handle sampling message callback. So this function will be used by the clients to answer to the sampling request made by the server. So here we receive the context and the message that is sent by the server. And then here we simply use Anthropic with the message to generate the output. So we extract the prompt here from the message using the content text. Then we make a call from our client's AI, so here Anthropic client, and then we return a specific type that contains the answer. Then it will be able to be read by the server to make and generate the final output of the tool. Now in the main function, it's simple. Here we create an SSE client that connects on localhost to our MCP server. And here the important part is in the client session, we add the sampling callback. So handle sampling message. Now I initialize the session. I just send a ping to make sure it works, the connection between the client and server, and then I call the generate poem tool. So if you remember, now the server will make a call to the client to generate it, get the output, and then send back the response. So we can now dive into running the example so you can see that it works. So here I will first run the server. The server is running. And now I will run our clients. You will see that here we receive some call on the server. It makes back a call to the client, generates the poem, and then we display the text here. So if we summarize what happened, we have a server, we have a client. The client makes a tool call, but the server needs the client's AI to do some work. The server makes a call to the client to get some outputs. It receives back the answer, makes a few extra steps of processing, and then return the final output to the client. So the server is able to use AI without relying on its own infrastructure. Okay, so now we clearly understand that using sampling, you can leverage some AI capabilities from the client on the server without using your own LLM or calling your own APIs. But now I want to quickly compare the difference between using MCP sampling versus your own backend LLM. So when you use sampling, the main benefits are that you save money because you don't run the infrastructure and you don't pay the tokens. You protect user privacy in a sense, because if the user chooses to use a local LLM, your server will use that LLM without sending the data to other providers. It's also flexible on the AI choice because the user has the full control on which AI is used. The user also have control on the input and outputs, so it can approve the requests you made and also approve the output from the client LLM. So it gives better control to the user. And finally, it scales easily because you don't run your own LLM on the backend and you don't make API calls. So it's easier to not get rate limited or reach limits on your API keys because everything runs on the client. So if you have 10 clients using your backend, each client will use its own capabilities to provide AI. Now, the drawbacks are it depends heavily on the user devices. The user devices can be slow or they can use shitty LLM, and then you will get shitty output for your tools. It's also slower in some cases because of the user device and maybe the network condition on the client. So lots of things can happen there. And finally, there is kind of a learning curve because now the user maybe needs to learn how it works and that it can control the input and outputs that you send to the client before they are generated and sending back to the server. To conclude in a few words, you now understand that using sampling, you can invoke some client AI capabilities on your server. You also understand the drawbacks between using MCP sampling and running your own LLM on the backend. Sampling is an advanced feature of MCP, and you can totally use MCP without sampling, but I think it's useful in some cases, especially to reduce the cost on the server side. Give it a try. Let me know if you have some interesting use case of sampling, and see you in the next one.